All right, with monoclonal antibody production, what these monoclonal antibodies are large quantities of a single type of antibody, hence monoclonal, one clone of a particular type of antibody made to a specific antigen, and they come from a single type of B cell clone. And what happens generally in the production of these monoclonal antibodies is you take an animal that's been injected with a particular antigen, and then it produces a plasma cell or a B cell to that. That animal's plasma cells then get treated a certain way. They're isolated from the blood that's drawn from them, and they're removed and fused with an immortal tumor cell line. So if you can think back to when we talked about cancer, we talked about HeLa cells, these particular types of cells that can divide endlessly. And you fuse that plasma cell with this immortal tumor cell, and what you get is a hybridoma formed. And this hybridoma can now start to form, divide endlessly, and continually produce these different types of antibodies. Okay, so here's your mouse, for instance, and you take this antigen, you inject it into the mouse, okay, and then the mouse produces some B cells, these plasma cells that are making antibodies specific to this particular type of antigen. And then you fuse it with a tumor cell, such as a HeLa cell, and then these form what are known as a hybridoma. Okay, and we said this hybridoma can divide endlessly and produce massive amounts of these different types of antibodies. And these antibodies can be used for a variety of different types of treatments. We can give them to sick people. We can, look for pregnancy or different types of ailments that may have occurred. So your hybridoma now, when this thing particularly or specifically divides and endlessly produces a different type of antibody, these monoclonal types of antibodies now are all specific to this particular type of antigen that we treated the cell with. Okay, so whatever it happens to be. So this could be human chorionic gonadotropin, for instance. We inject it into the mouse. The mouse produces plasma cells to HCG. This cell now gets fused with a particular HeLa cell, producing a hybridoma. And this hybridoma produces these antibodies that are we could say, HCG. So if we want to use them in a pregnancy test of sort, these things will all of these antibodies will bind to HCG and then give us a particular, outcome. If we're producing a large amounts of HCG, that means we're pregnant. If that's in our urine, we pee on a stick that's got these monoclonal antibodies to that, then we know that we're pregnant. Okay. Some of the other use, the treatment of rabies. So what we can do is we can take that rabies virus, we can inject it into the mouse and get the mouse to produce these plasma cells. These plasma cells that are producing antibodies to the rabies virus can be fused with the tumor cell. That tumor cell and plasma cell form that hybridoma, and then what you get are these monoclonal antibodies here that are working against the rabies virus. And now we can inject those into the human or the person that's got the rabies, and then that's going to allow the immune system to catch up and get rid of that rabies infection. Some of the other treatments for or uses of these types of things, we talked about the pregnancy testing, malarial infection, HIV, heart attack, stroke, etc. So there's all sorts of uses for these monoclonal antibodies. And last thing here I want to talk about is allergies. And these are basically just exaggerated immune responses to particular antigens that may be in the environment. Okay? And the most common allergies involve antibodies of the IgE class, so the immunoglobulin E. And when these plasma cells secrete the IgEs to a specific antigen, say on some pollen, some tree pollen or something like that, this is where you get hay fever, okay? And some of these antibodies are attached to mast cells, which are found in the body's connective tissue. And when these allergens enter the body and they interact with those antibodies that are attached to those mast cells, these mast cells start to release histamine, and then you get a variety of these inflammatory types of substances that are released, and this is what's causing the symptoms of the allergies. In other words, you get the dilation and increased permeability of the small blood vessels. So now you've got these itchy, watery eyes. You've got the red eyes, the redness around your eyes, the runny nose. All of those types of things are a result of this histamine being released from the mast cells as a result of the interaction with the allergen and these IgE associated immunoglobulins. And what they're going to do is they're going to cause the blood cells to become more permeable. They're going to swell. Blood's going to rush to them. You're going to have, that localized fever around your eyes, which is why they're red and kind of swollen and watery and all that. So those are just basically some of the ways in which these allergens trigger an immune response. And really, it's kind of a hypersensitive immune response because some people are allergic to things and others aren't. So it's just this overactive immune system that's causing these things. Okay? So if you have any questions, make sure, of course, you write them down, and we'll talk to you soon.